Hello everyone, I'm Professor Rekha Murthy from Sai Vidya Institute of Technology from AAA department. So I'm here to discuss this third experiments related with the machine laboratory one, that is parallel operation of a two dissimilar single phase transformers. What is the aim of this experiment is to connect the two single phase transformers of a different ratings in parallel and to study how they are going to share a common load. So before go with this experiment, we should know that the transformers are said to be connected in parallel with when their windings are connected to HV or LV bus bars, which will be common to both. So to meet that additional demand on the power system, it becomes necessary either to replace that existing unit by unit or of a greater capacity, or to install the additional unit to carry a portion of the additional load. Sometimes two or more units will be connected in parallel, which will be preferred over a single unit. So in this arrangement, what will happen? The primaries of the two or more transformers will be energized from the same source, and the secondary will be connected to the supply with the same load. So the following conditions need to be satisfied in order to avoid that any local circulating current, and to make ensure that the transformers is going to share a common load in proportion to their kVA ratings. So what are the conditions need to be satisfied? The primary winding of a transformer should be suitable for the supply system voltage and the frequency, and the transformers should be properly connected with regard to the polarity. And the third thing is the voltage rating of both the primaries and the secondaries should be identical. That is the transformation ratio. The transformer should have a same transformation ratio. The fourth point is the percentage impedance should be equal in magnitude, and it should have a same X by R ratio. So let us see that how exactly all these conditions can be satisfied when the more than two transformers are connected parallel, and how it is going to share the load, how the power can be shared by each of the transformers. So here, what are the apparatus to be required to conduct this experiment? So we require the ammeters 0 to 5 amperes, and the another ammeter of 0 to 10 amperes, and 0 to 20 amperes, 0 to 30 volts. So we require the voltmeter 0 to 30, 0 to 300, 0 to 600 volts, as per what we had considered for the previous session experiments. And we require the wattmeter, that is UPF wattmeter. We require the 3 UPF wattmeters, and 2 kVA transformer, and one more as a 1 kVA transformer. For these two, the supply will be given through the auto transformer. And we require the choke coil and the resistive load bank, which will be connected on the secondary of the part of the circuit. Let's see the circuit diagram. So where here we can observe that this first part of a circuit is it is an OC test what we had conducted, and this was the SC test what we had conducted. Almost it is similar. The difference is we are going to separate the one more the transformer. We have to connect. We need to connect it the other part of the circuit, that is with the means of the SPST. So here the two transformers, the primary is connected through the supply, and the secondary part of this is being connected in parallel with the means of this SPST switch. We are going to connect it to the additional wattmeter and the ammeter, and here this part of the circuit is connected to the resistive bank with the choke coil. So what will be the procedure? The connections will be as shown in the figure. It will be made. And the second thing, with the SPST switch, it is open, the supply is switched on. The reading of the voltmeter, which is connected across this K, is observed. If it reads 0, as what we did in the previous session, if it reads 0, then what we have to do? If it reads 0, which means that the two secondary EMFs are opposing, then the switch K will be closed. then the switch K will be closed. Okay, if it is reads twice, what we have to do? We need to interchange the secondary of the either of the two transformers. Okay, and the no load reading will be noted down. SPST switch is closed now. When this voltmeter is going to read 0, SPST switch is closed now. This K1 is closed, and we have to note down the no load readings. So loading will be continued in steps of the 2 ampere by varying both the resistive and the reactive loads. And the K should be taken in such a way that the ammeter which is connected to the secondary, it should not exceed the rated current of the corresponding transformer. So decrease the load to a 0, then open that SPST switch to remove the load and then open the supply. So perform similarly the short circuit test on both the transformers to determine their equivalent impedance. So short circuit test is conducted on each of these two transformers separately with the meters which will be connected onto the primary and the readings will be tabulated. So for these two transformers, we need to conduct the short circuit test separately. Okay, fine. So what will be the readings which you are going to take from the short circuit test? One transformer will be of a 2 kV and another transformer will be the 1 kV. And for the 2 kVA, the rated current is 8.7 amperes. So what will be the voltage? This is the same value which you will get it as what we did in OC and AC test as the first experiment. And we need to repeat to find out the VSC and WSC for the 1 kV of a transformer. Obviously, it will be half of this value. So it is 4.35 amperes. Then the calculation we have to find out to get the respective values, that is from the transformer A. From the 2 kV, we can get the what is ZA, that is as usual, VSC by ISC, and R, that is resistance, WSC by ISC square, so that we can find out the reactance. So it is square root of Z square minus R square. Then we can write that ZA as nothing but RA plus J into XA in the rectangular form. And also it can be written in the polar, that is ZA with an angle of psi A. So here the final, this will be the with the different ratings. As I told you, the 2 ampere we are going to vary, then 4 amperes. This is all the variation with respect to the resistive load bank. And it should not exceed 12 amperes. And this is the respective voltage wattmeter reading, IA, IB, and IA dash and IB dash values which will be taken up. So IA dash can be calculated by using this formula, that is IL with an angle of minus psi L, which is multiplied by ZB at an angle of psi B divided by ZA into at an angle of psi A plus ZB at an angle of psi into B. So this is nothing but the primary of the first the transformer, that will be given by the load current multiplied by the other part of the transformer impedance divided by the addition of the impedances of the two transformers, transformer A and transformer B. And also we can similarly carry out the same calculation for the transformer B. So the current which is provided, the IB dash will be equal to the load current IL with a lagging power factor multiplied by, this is the impedance of the other branch. So this, if this is a current with respect to the transformer B, then this will be the impedance of the transformer A divided by the addition of the two impedances of both the transformers. So this is how we can calculate the IA dash and IB dash. The further calculation, when we are going to find out the equivalent resistance, circuit, then these are the parameters which you have to take it out. For a transformer 1, with the 4 kVA, if you consider, so it is Z01 is equal to VSC by ISC, and R01 will be the WSC by ISC square, and X01 will be equal to square root of Z square minus R1 square. Second transformer, if it is considered as 1 kVA, so it is Z02 is equal to VSC by ISC, and R naught 2 is equal to WSC by ISC square, then X naught 2 will be equal to square root of Z2 square minus R2 square. Since here we are using transformer 1 as a 2 kV, so you can prefer for 2 kV, and transformer 2 will be the 1 kV. Then further we can find out what will be the I1 current and I2 current by using the formulas. So this completes, this will be the theoretical equations which you can carry out, and further we can find out how much the current or the power which is shared by the secondary by the two transformers. Okay, when you're going to use the equal ratio, when you're going to use the unequal transformers and similar transformers conducting a parallel operation. So finally we complete the two single phase transformers of a different ratings will be connected in parallel, and we are going to find out how much they are going to share a common load. Thank you for watching this video.